Hello, future software testers. If you're here prepping for the ISTQB Foundation Level V4, good news. You've landed in the right place, and let me tell you what this preparation is all about. So, basically, we're launching a compact mini series composed of 4 videos that will walk you through a full exam style foundation level test. This is One Run Academy, and we build mock exams that mirror what you'll actually encounter, from topic distribution to K difficulty level, language, and exam style. In short, expect a realistic, high quality practice experience. Here's how each video will work. I'll read the question, give you a moment to think, then we will walk through the reasoning. And along the way, I'll give you some quick tips to spot the common traps examiners love to use. Alright, let's not make this introduction any longer and let's begin our journey with question number 1. Which of the following statements resembles a valid test objective? A. Validation of the work product quality, no verification is required. B. Verification of the work product quality, no validation is required. C. Verification of software compliance with legal and regulatory requirements. And finally, option D. Verification and validation of software perfection and the absence of defects. Pause now if you want to think about it. Alright, no rocket science here, and this is a pretty straightforward question. This question is challenging you to pick the option that resembles a valid test objective. Very simple. Looking at options A and B, we can immediately recognize that those are far from being test objectives, simply because software testing is concerned with both verification and validation of the work product. As a quick refresher, verification is where we make sure that the software behaves correctly when we compare it to the predetermined requirements, while validation, on the other hand, is the process of making sure that the software meets the needs of the end users. Moving to option C, I would say this one is a very good candidate to be the correct answer. You see, verifying the legal or regulatory requirements is actually a test objective. It's important to understand that failing to meet these requirements may cause the software to be returned back to the development team. And this process is very time consuming and, of course, not free. Not to mention any lawsuits, especially in serious domains. So just imagine an e-commerce app that took several months to develop, for example, and then it fails to calculate the tax correctly. Just think of the legal claims and damaged reputation. I would say totally catastrophic. Now, let's keep option C in mind and let's take a quick look at option D. Now, the absence of defects claim is, let's say, inaccurate. As a matter of fact, this contradicts one of the test principles, which says testing shows the presence, not the absence of defects. And that makes option D far from being correct. That's great. Let's check if our analysis is correct. And voila! Option C is indeed the correct choice for this question. It's indeed the best match. Of course, you can pause the video for one more time and read the explanation provided. Although I feel we have covered it thoroughly, so let's jump to the next question. Time for the second question in our journey, so let's read it together. You're reviewing the code of a calculator mobile app, and you found that the developer never implemented a mitigating procedure to handle when a user tries to divide by zero. But the UI designer made the equal button untappable if a division by zero is detected, which will make the code unexecutable and prevent the application from crashing. Which of the following statements most describes this situation? A. We can say that the app has no issues because the defect will never appear. B. Even if the defect will never execute at the moment, it might be in the future. C. This is an example of trivial errors where no actions should be taken to save time and effort. And lastly, option D, the application must warn the user not to try to divide by zero as this is mathematically impossible. Pause now if you want to think about it. Very nice. So, I believe you got the main idea behind this question. The code itself is defective because it was written without handling the exception of dividing by zero. However, this defect cannot be executed, at least at the moment, because when the UI detects both zero and a division operation, it will prevent the equal button from being tapped by the user. This means that option A is, of course, not correct. This app indeed has an issue and a big one too. We can't pretend everything is okay and ignore such a major logical anomaly. Moving to option B, I would say it seems valid. Yes, with any future app update or any UI change, the app might allow the equal button to be tapped while dividing by zero, allowing the defect to get executed into a failure. So, this defect must be fixed as soon as possible, and we should not rely on the UI to act defensively. So, let's put option B in mind as a possible choice for this question. Now, option C defies common sense and defies even logic when it assumed this is a trivial error, as it's directly related to the core functionality of the app and cause it to crash. So, no, option C is not the one we're looking for. Now, moving to option D, I would say it's unmistakably a bad option. You cannot conceal such a defect with another mistake of turning the app into a non user friendly disaster. So, obviously, the correct choice in this case is option B. And here's your explanation if you want to pause and read it. Now, let's move to the subsequent question. Alright, let's dive into the third question together. To boost the success and rating of their disliked and glitchy calendar software, your organization decided to hire a highly skilled tester. After months of testing, the calendar software seems to be almost bug free. But the number of downloads and the app's rating are not improving that much. From the perspective of testing principles, how do you explain this situation? A. Exhaustive testing is impossible. B. Absence of defects fallacy. C. Testing shows the presence, not the absence of defects. D. Tests were out. Pause now if you want to think about it. Great question, and let's make a quick overview. So, a calendar app which had a lot of problems in the past was fixed after months of testing and debugging. But the newer version, which is really good, is not making that much of a success in the market. And we are asked to explain this bad luck. Well, we can't analyze bad luck, but we can analyze the options. So let's take a look at option A. Now, exhaustive testing does not seem like a good choice because nothing is mentioned about testing everything in this context. So, option A is out. Now, option B looks like a valid explanation. This is because hiring a tester with high experience plus spending a ton of time or money fixing the software anomalies cannot alone guarantee the success of the software. Simply put, many other variables are parts of the formula here. For example, The user friendliness of the UI and its ease of use are contributing factors to the success. Not only that, but maybe the market competition is so high and there is almost no room for new apps in this category. Just bad luck. Next, option C and D represent principles of testing that are far from being relevant to the context of this question, and obviously, none of them should be considered a correct answer. So, the final conclusion here is very obvious. Option B is the correct choice for answering this question. Testing definitely can help, but it's not magic. All right, we're making great progress, so let's keep the excitement in the air and let's read question number 4. Your manager assigned you the task of writing a script for automated regression testing. Which of the following activities is the one would typically come before you do this task? A. Analyzing project risks. B. Writing test cases from test conditions. C. Defining test objectives. And lastly, option D. Logging test results. Pause now if you want to think about it. All right, so the key to answering this question correctly is to find out what test activity you were assigned by your manager. You were assigned to write an automated test script, and we all know that this belongs to test implementation. So far, so good, but the question asks which activity comes before the test implementation. So, do you remember what comes before test implementation? Well, it's test design. From this point, everything is going to be very simple. We need to analyze each option and see which of them is relevant to test design activity. And I believe option B is the one that truly represents a test design activity. To verify, option A is related to test analysis, option C is related to test planning, and option D is related to test execution. Hence, it's confirmed. Option B is the correct choice to answering this question. That's awesome, and let's see what we have next. Excellent. Question number 5. Consider the following document. Now, you can see it seems like a checklist of some goals or milestones like achieving 100% test case execution and logging all the defects. And the question is challenging us to know which test activity produces this testware. As usual, 4 options are provided. A. Test planning work products. B. Test monitoring and control work products. C. Test analysis work products. And lastly, option D. Test completion work products. Pause now if you want to think about it. Very well. So the idea here is to understand what this piece of testware is, right? In fact, some may assume this document is part of the test summary report, in which the test status is reported. However, I don't feel this is truly the case. You see, something like the last row saying that a minimum of 80% of defects are fixed defies this assumption. It seems like a group of conditions and not declarative statements. Now, looking back at the other lines, we can see them clearly as conditions that need to be fulfilled. So, I believe it's very safe to say that this document is not a test summary report. But what could it be? Well, I believe it's a set of exit criteria for an iteration or test cycle. And from this point, it's fairly simple. Just ask yourself, which of the test activities produces the exit criteria? Of course, it's the test planning activity. Hence, the correct answer is option A. Let's check our analysis. Great. Indeed, our analysis is very solid and option A is the best choice to answer this question. Alright, folks, we reach the halfway point of this video, and if you feel it's useful to you, please hit that like button. Also, if you want to practice more, you can always check the first comment, and there you'll find three links. One is for the exam preparation course, which packs 6 additional exams with thorough explanations. And for each exam, you can choose either the exam mode to assess your current level or the practice mode to acquire deeper understanding. In this video, we've been using the practice mode the whole time. The second link is for a complete ISTQB Foundation Level V4 course. And this one is more than 14 hours of software testing content, if I'm not mistaken. This course also has another 3 additional exams, plus a lot of quizzes after each lecture and a practice to solve the exam sample question. And if you want both, you can always grab the bundle. This is the third link. All courses are on the Udemy platform. Thanks for your support, and let's get back to our ISTQB Foundation Level Test Preparation series, and let's move to the next question. Question number 6. Let's read it together. Your test manager asks you to create the exit criteria for the current iteration of a news reading application under development. According to your knowledge, writing the entry and exit criteria is a managerial role. What would be the most suitable response to your manager's request? Again, 4 options are provided. A. You reject the delegation because testers cannot take the role of managers. B. You accept the delegation, but you must get help from other testers in the team. C. You accept the delegation as testers can sometimes play different roles. And lastly, option D. You reject the delegation unless you get approval from other stakeholders. Pause now if you want to think about it. So, how to approach this context? Well, you've probably noticed that it's a news reading application. Not a big deal, right? I mean, it's a relatively typical project and probably does not contain critical security aspects. It's not a banking app. Plus, the task itself is relatively easy, which is writing the exit criteria and not something very complicated like writing the test approach. Furthermore, in any business domain, including software development, it's the norm for managers to delegate minor tasks to team members to boost their ownership and grow leadership inside them. So, yeah, nothing out of the ordinary here. Hence, the correct answer is option C. And generally speaking, this delegation is more commonly seen in agile software developments, where you can find many instances when a tester may play the role of a business owner, for example, and collect the requirements from the client. Let's move to the next question. Great. The next question is number 7, and let's see what we have here. Arrange the following development activities according to the level of independence, starting from no independence up to very high independence. 1. A tester from the same organization is reviewing the developer's code. 2. A developer reviewing his own code. 3. Two developers reviewing each other's code. And number 4, a freelancer tester reviewing the developer's code. Pause now if you want to think about it. Awesome. So, without a doubt, the correct answer is option D. And it all boils down to your understanding of the level of independence in each of these instances. So, a developer reviewing his own code, that's 2, is the least level of independence. Then we have 2 developers reviewing each other's code, that's 3. take the level of independence a level up, and we are on number 1, an internal tester reviewing the developer's code. And of course, the highest level of independence is when you outsource someone to review the code. So, yeah, the correct order is 2, 3, 1, 4, which translates to option D. That was an easy one, and let's see what we have next. Let's see what question number 8 is all about. Among the following business domains, which is the least suitable for the whole team approach? A. Self-driving car software. B. Mobile games application. C. Video streaming application. And lastly, option D. Discussion web forums. Pause now if you want to think about it. Great. So, this question is challenging you to figure out the domains where the whole team approach may not be suitable. To answer that, we must understand that in the whole team approach, everyone with the required knowledge can perform any task. The rhythm is fast, and the level of test independence shifts towards the low side. That being said, the whole team approach is indeed an excellent choice for projects that require high pace. For example, developing a game for mobile devices. In this specific instance, you'll need a fast paced development model as you're continuously adding new game levels and features, and you're probably changing the layout and the graphics quite often. However, when talking about developing safety critical software, well, these fast paced, low test independent environments are not ideal. For instance, autonomous driving cars, avionics software, and surgical robot controllers. These domains require a high level of test independence that is not so welcome in the whole team approach. Hence, the correct answer to this question is option A. Self-driving car software is the least domain that can make friends with the whole team approach. Let's see what we have next. Alright folks, we're almost there, and now is the time for question number 9. Let's read it together. Which of the following statements are not true regarding SDLC? A. V model is an example of sequential SDLC. B. Prototyping is an example of incremental SDLC. C. In the shift left approach, reviews come before dynamic testing. And lastly, option D. The spiral model is an example of iterative SDLC. Pause now if you want to think about it. Great. Let's analyze each option to see which of them is the least true. Starting with option A, yes, this is a very true statement. The V model and the waterfall models are examples of sequential SDLCs. So, option A is not our hunt. Moving to option B, and it seems like it's the one, because prototyping is an example of iterative SDLC model and not an incremental SDLC model. However, let's verify the remaining options. So for option C, no one can deny it's actually true. Reviews come before dynamic testing in the shift left approach. As a matter of fact, reviews always come before dynamic testing in almost any SDLC model. You know, the early testing thing. Finally, option D also represents a true statement. The spiral model is an example of an iterative SDLC model. Let's verify. Yes, confirmed. Option B is the correct answer to this question. Awesome. The last stop. Question number 10. Consider the following document. Given the end user has a credit card entity stored in his payment options. When the end user clicks the delete credit card button, then the credit card should be deleted from the database and no longer appear in the user profile. The question is, to which of the following development approaches does this document belong? As usual, four options are provided. A. Behavior-driven development. B. Test-driven development. C. Domain-driven design. And lastly, option D. Feature-driven development. Pause now if you want to think about it. Alright, so a very easy one, I must say. And we can all agree that the correct answer to this question is option A. Of course, one of the most recognized characteristics of BDD or behavior driven development is that it uses the given when then format to express the software requirements. Alright, folks, with that, we reach the end of part 1 of our series. I hope you're excited for part 2 as I am. Thank you very much for watching, and I'll see you in the next video. Have a great day.